won't do it today. I'll do it on Sunday because that's what the parents said will be feasible for them to come. So this Sunday I'll do that meeting. Okay, I won't do it today. I'll do it on Sunday. Okay, because the other day I did a meeting, another meeting on Friday. So a lot of parents suggested that instead of having it in on weekdays, you better have it on Sunday. So which I agree and understand. So I'll do the parents meeting on Sunday, both for the JE students and for the NEET students. Okay. But I didn't get proper answer and I don't know how to do. Okay, I will do them. I will do them. So few questions were on mole. Please teach those. Can you please do that? Yeah. I'll be doing them. I'll be doing them. Before that, I'll just show you some small photos. Photos. I don't go to album, but I want to go to photos. Okay, so I want to show you, this is how the s orbitals look like. So this is how the s orbital looks like. This is the, so after Heisenberg's uncertainty principle, they came up with Schrodinger. Actually, after the uncertainty principle, they stopped speaking of electrons. They started speaking of electron cloud. So an electron is like a cloud, and where is that cloud present? So that cloud is present up to a particular value, and then they started speaking of probability of finding an electron within a given space. So what we now call as an orbital or something is nothing but the probability of finding an electron in a given space. So in the first shell, the probability of finding the electron within that 0.59 angstrom units is high. So that became the so-called radius. So this is how 1s looks. This is how 2s looks. In 2s, if you see, there is a particular region where the probability of finding the electron is 0. Okay, such a region is what is known as a node. So in 2s, there is one node. In 3s, there are two nodes. In 4s, there are 3 nodes, and so on. In 1s, there is no node. Okay, a node. What is a node? A node is a point where, is a region where the probability of finding an electron is very low, almost 0. Okay, so it is 0. So probability of finding an electron there is 0. So that is a node. So two points here. S3s has 2 nodes. 4s will have 3 nodes, and so on. Okay, there are 2 kinds of nodes. That is, these are all the radial nodes. There is a radial node, and then there is a angular node. Okay, those will not come up in S. They will come up in the other orbitals. Okay, so here. So this is the p orbitals. Okay, p orbitals. If you look at this rectangle, the slab, the probability of finding the electron there is 0. So that is a nodal plane. Yeah. So for pz, the nodal plane lies in the xy plane. So this orange, this violet thing. Similarly, px, the nodal plane is perpendicular to y. So perpendicular to y. So that's the nodal plane. This is for the x. So the nodal plane lies in the xyz plane. For px, it lies in the yz plane. Then for py, it will lie in the xz plane, and so on. Now in the d case, d orbitals, there are 2 such nodal planes. Now understand the L value. What is the L value for P? L value for P is 1. So how many nodal planes does it have? 1 nodal plane. Okay. So these are known as the angular nodal planes. Why? Because it depends upon the angular quantum number or the azimuthal quantum number. So D has how many? What is the L value for D? 2. So it has 2 nodal planes. So these are known as the angular nodal planes. Two nodal planes, two nodal planes. So angular nodal planes. Okay. Then you have something called as the radial nodal plane. So this is one formula which I would like advise all of you to remember. Total, so number of angular nodes, that's what I was just trying to tell you. S is 0, P is 1, D is 2, F is 3. What are the 0, 1, 2, 3? These are the L values. So the number of angular nodes, angular node, a node is a point where, or is a region where the probability of finding an electron is 0. So there it is 0, 1, 2, 3. So the L value indicates the total number of angular nodes. The total number of radial nodes is n minus L minus 1. So these are two formulas that I would advise you to remember. The total number of radial nodes. Radial nodes are those points where the probability of finding the electron is 0. So these are radial nodes. These are radial nodes. Okay, so these nodes are the radial nodes. I can show you radial nodes here. I can show you radial nodes here. Planar nodes only giving. Radial nodes, it's very tough to draw formula, draw a diagram. So radial nodes, please remember this, the number of radial nodes is n minus L minus 1. So for the s orbital 1s, there is no radial node. Similarly, for 2p, there is no radial node. Now for 3p, there will be one radial node. For 4p, there will be two radial nodes. So 2p, 0 radial nodes. So same way 3d, 0 radial nodes, 4d, 1, 5d, 2, and so on. Nodes are those points where those regions where the probability of finding an electron is 0. Okay. Oh, did I show you? Oh God, I would have many messages. Yeah. Were you able to see the pictures that I showed you? Dinesh, to your parents, I'm going to tell that Dinesh is not working at all. Can you explain again what you start? Yes, you all have to come 2-3 minutes before. You all come in the last minute and you keep disturbing me. Please repeat, please repeat. Even now, if you see, half of them would still have not joined. Only now they have come. Okay, still there are some 10 people, 15 people who have not joined. It is 12 minutes beyond my class time. Then they'll keep saying, sir, repeat, repeat. Now it becomes very difficult. Yeah, so yeah, number of nodal planes in the 2s orbital is 1. Are there different kinds of nodes? First, write down a node. Node is a region in space where the probability of finding an electron is 0. A node is a region in space where the probability of finding an electron is 0. Okay, then you make nodes. So the number of nodes in SPDF. So you can write down there are two kinds of nodes. Angular nodes and radial nodes. Angular nodes refers to, it comes from the L value. Angular number of angular nodes is equal to the L value. So s orbital has 0 nodes, 0 angular nodes. P orbital, s orbital, spherical. So at any angle you will find something. P orbital will have one angular node. So here I have shown you the Px, Py, Pz, the glass slab that you see, and that the probability of finding an electron is 0. So here you see I have shown you the angular nodes of Px, Py and Pz. So on those glass slabs, the probability of finding an electron is 0. So those are referred to as the angular nodes. The angular node is equal to the L value, the azimuthal quantum number. The azimuthal quantum number. Okay, now I am showing you the nodes in the case of d orbital. D orbital, the glass slabs that you see, those are the two planes where the probability of finding the electron is 0. So d orbital, what is the L value for d orbital? 2. So there are two angular nodes. So the number of angular nodes is equal to the L value. Okay, then now I'm going to show you the radial nodes. So these are the radial nodes. They look spherical. So as you keep moving away, the probability of finding electrons in certain spaces becomes 0. Where does this come from? This comes from Sommerfield's theory and from Schrodinger's theory. So Schrodinger gave us a wave equation. So when you solve for that wave equation, this is how it looks. So what I am trying to tell you is an electron and an atom and an electron revolving around the nucleus is very complicated. It is not so easy that I can say, hey, look, this is how the electron is revolving. We can only keep guessing because an electron is so small that you can't say anything about it. Okay, so these are the radial nodes. So in 1s there is no radial node. Similarly in 2p there will be no radial nodes. In 3d there will be no radial nodes. 2s there is 1. Similarly in 3p there will be 1. Similarly in 4p there will be 2, and so on. So there are these two kinds of nodes which are there. So you have the radial nodes, you have the angular nodes, and then you have the radial nodes. Together you will get the total number of nodes. Angular node is equal to L. L value gives you the angular node. So S will have 0 angular nodes. P will have 1 angular node. D will have 2 angular nodes. F will have 3 angular nodes. Why? Because the L value for S is 0, the P value for L is 1, D value for L is 2, and the F value for L is 3. So it will have 3 angular nodes. Angular nodes refers to planes where the probability of finding an electron is 0. Okay, then you have the radial nodes. Radial nodes, basically you can have n is equal to 1, S will have 0 radial nodes. But when n is equal to 2, the number of radial nodes will become n minus 1. So here there will be 1 radial node. Suppose n is equal to 3, here it will have 2 radial nodes. Here if suppose n is equal to 4, it will have 3 radial nodes. Radial nodes indicate the points where it is basically a spherical surface where the probability of finding an electron is 0. In case of P in n is equal to 1, there is no P. Only here P starts. So here there are 0 radial nodes. Here there will be 1 radial node, 2 radial nodes, 3 radial nodes, and so on. So 1 here, 2 here, 3 here, and so on. D, there is no D here. There is no D here. Here there are 0 radial nodes. F, there is no F here. There is no F here. There is no F here. There is F here. So here there are 0 radial nodes. So here there is 1 radial node. Here there are 2 radial nodes. Here there are 3 radial nodes, and so on. So in questions, when they ask you to find out the sum of radial nodes, this is how you can find out the sum of the radial nodes. So sum or total number of radial nodes are the angular nodes plus the radial nodes. So that will give you the total number of nodes. So nodes are those points where the probability of finding an electron is 0. Yalini, there is nothing to understand in this. There is nothing. It's just a statement which is given. So I'm telling you the statement. Please try to learn it. Okay. So this is how you can learn it. That the total number of angular nodes is equal to the L value. Please write that statement. There is nothing here to understand. The total number of angular nodes. First, please understand planes where the probability of finding an electron is 0. That is where. So now I am explaining it to you by way of a diagram. So here is a diagram. Here is a diagram. So for P on this glass shell, by the shape of the orbital, you can see on the glass shell, you cannot find any electron. Here on this glass shell, you cannot find any electron. So I can see only one such plate. The other plate will come on this. So I will have to cut through the sphere anywhere else. So where there is a probability of finding an electron is not 0. So Pz, there is one angular node. We can keep saying that I don't understand. This is the PhD topic. I don't have to explain it this way. I can just give you the formulas and move on. So we just remember the formulas and then move on. Yeah. Yes, they were asked in the test. That's why I'm telling you. Harish, let us talk. There is nothing. Here I am giving you the formula for the nodes. Here it is. I am telling you the number of angular nodes is equal to the L value. So please make a note of this. So S has 0 nodes, P has 1 angular node, D has 2 angular nodes, F has 3 angular nodes. What do you mean by angular nodes? Angular nodes are those planes where the probability of finding an electron is 0. So now I am explaining, look here, P, you will have 1 angular node. In case of D, by the shape of it, there will be 2 angular nodes in the XZ plane. You don't need these things. You just need to know the number of angular nodes. So I don't have to show this to you. The only thing that is there in the syllabus is to memorize it. So please memorize it. Px, Py, Pz are not exactly -1, +1, 0. They are not related. Px is not -1, Py is not +1, and Pz is not 0. But yes, Px, Py, Pz are 0, +1, -1, or -1, 0, +1. But it is not that this is associated with that, that is associated with that. No. Angular nodes. There are no angular nodes for S. Yes, they are the same. Yes, are we able to get it? Yalini, can we understand this concept of angular nodes? Because it is spherical. So I cannot draw any plane where the probability of finding an electron is 0. So please understand that. Yeah, so how questions came in your exam? No, the same type of questions will come. Okay, so angular nodes is 0. Then I am talking about the radial nodes. So radial nodes I am explaining to you the total number of radial nodes. So how many radial nodes do you have? So the radial nodes formula, basically total number of nodes will be n minus 1. Total number of nodes will be n minus 1. So total number of radial nodes will be n minus L minus 1. N minus L minus 1. So this will give you the total number of radial nodes. Total number of nodes is n minus 1. So here, total number of nodes is n minus 1. Total number of angular nodes is equal to L. So total number of radial nodes is equal to n minus L minus 1. Number of angular nodes in S is equal to 0. In L is equal to 1. Sorry, SP. D is equal to 2. F is equal to 3. Equal to the L value, also called the angular momentum quantum number, which we popularly call it as the azimuthal quantum number. Okay, which we popularly call it as the azimuthal quantum number. So this is the number of angular nodes. So from here you will get the number of radial nodes. The question is, they will ask you, S has how many? 3S. 3S has how many nodes? So here n minus 1. So n is 3. 3 minus 1. 2 nodes. Are these spherical nodes? Are these spherical nodes? I mean, are these radial nodes or angular nodes? So S has 0 angular nodes. So these are both radial nodes. So that is the kind of question which you will be asked in the exam. Nodes will only be present in subshells. Node is a Baba, that is where an electron is. Wherever there is an electron, there only. So node is basically a region in space where the probability of finding an electron is 0. These are the complications which have been brought in by Schrodinger's wave equations. So that a wave equation can be solved. Okay, so there is maths there. So if you go to an IIT, they will teach you how to work on that maths. If you do a PhD in quantum physics, you will again learn it there. Okay, so we won't need it. So if they simply say nodes in question, we have to find the total nodes. Yes, which is equal to n minus 1. Is angular and radial nodes related to? Yes, they are related to angular and radial momentums. Yes. Formula for radial nodes, I have told you, n minus L minus 1. Definition of radial node. Definition of radial node is a region in space where the probability of finding an electron is 0. It's the same thing for both. It is the same thing. Yeah. Next is homework questions. So let us understand this whole concept of nodes, because there were a few questions which were there in the exam based on that. Okay. So I thought I should clarify that first. Yeah. So if it is understood, we will move on. What is the difference with nodes? Okay, so I will, one last time, I will show you these photographs. Look, a P shell, a P subshell is dumbbell shaped. Because it is dumbbell shaped, when it reaches the origin, the dumbbell that comes to 0, right? Because it is one circle below one circle. So in the plane where the two circles meet, I cannot find an electron. So that is a nodal plane. And that is called a radial, that is called an angular nodal plane. Yeah. So this is PZ. That means this is along the Z axis. Okay. So this is the electron cloud is here. That means the electron can be found here. Electron can be found here. So in this plane, here you cannot find the electron, right? So this is a angular nodal plane. Any other plane that you draw, you are going to cut. You're going to cut this. So the probability of finding the electron here is there. Probability of finding an electron here is there. So you can have exactly one nodal plane for P. Now D is more complicated. D is like it has one here, it has one here, it has one here, it has one here. So now here on this plane, I can't find anything. On this plane also, I can't find anything. So S is spherical. Spherical, whichever way you draw, you will find an electron. So 0 angular nodal planes. Because you are drawing them at an angle, they are angular nodal planes. P, they are related to the angular momentum quantum number. They are related to the L value. That's when the correction which has been made in the angular momentum of an electron, MVR is equal to root over of L into L plus 1 H by 2 pi. So this L value here is what is called as the angular momentum quantum number, also popularly known as the azimuthal quantum number. Okay, so P has 1, D has 2, F has 3. So these are the number of angular nodal planes. Okay, now spherical nodal planes come because of the size. 1s is here. 1s is here. So here there is no nodal plane, no spherical nodal plane. But when you go to 2s, it is observed that you can find an electron here, you can find an electron here. In between, there is a thin zone where the probability of finding the electron is 0. Okay, so this is a radial nodal plane. Okay, now this is 1s, this is 2s. In the second shell, there is one such thing. In the third shell, there are two such things. In the fourth shell, there are three such things, and so on. This comes because of the size of the orbital. As the size of the orbital goes, the number of radial nodal planes increases by 1 for each shell. So now P is not there in 1, P is there only in 2. So it has no radial nodal plane. But when you go to 3P, now 3P is bigger than 2P, right? So when it goes bigger than 2P, there is one nodal plane which is coming up. Okay, so the number of nodes is equal to n minus 1. Number of angular nodes is equal to L. Number of radial nodes is equal to n minus L minus 1. Basically, this is the number of nodes, this is this. So, total number of nodes is equal to angular nodes plus radial nodes. Angular nodes plus radial nodes. Okay, so friends, this is the best that I can do. Yeah, yes, looks like it. Azimuthal is the name of it. If one dumbbell shape is present, it is 1P. Yeah, if two dumbbell shapes are present, then D is present. Yes, D is double dumbbell shaped. Yeah, okay, so this is the best I can do about this. There is nothing else. Others, we'll have to learn to come to class on time. Many of us are not coming to class on time. So I will just show you the slides once again. This is slide number 1. This is slide number 2. This is slide number 3. I was trying to explain to you that P cannot have more than one nodal plane. 2P cannot have more than one nodal plane, because whichever other plane you make, it will be cutting through that. Okay, so now let's get back and let's start our other works. Yeah, next Sunday, parents meeting is next Sunday. I will announce and I will send you. Yeah, definition of a node. A node is a region in space where the probability of finding an electron is 0. Yes, only formula and how to find out you keep in mind. Okay. Yeah. So the questions that we were working yesterday, I asked you, what is the first question I asked you is, what is the total charge? What is the total charge on 1 mole of electrons? What is the total charge on 1 mole of electrons? So 1 mole of any substance, 1 mole of any substance is 6.023 into 10 power 23 particles. So 1 mole of electrons is how much? Is 6.023 into 10 power 23 into 1.6 into 10 power minus 19. So this will be the total charge. Charge on 1 electron into total number of particles. So this is 6.023 into 1.6 into 10 power 4. So if I multiply this, 16 into 3 is 48, carry over 4. 16 into 2, 32, 36, carry over 3. 16 into 6 is 96. So it becomes 96368 coulombs, which I can say is approximately 96400 coulombs. Okay, so this number is an important number which we'll be working with later. So this is how you can find out the total charge on 1 mole of electrons. Okay, so this is the first question. Second one, what is the total energy in 1 mole of photon having frequency 5 into 10 power 14. Okay, so first, energy of 1 photon is equal to h into f. So that is 6.637 into 10 power minus 34 into 5 into 10 power 14. So when I work this out, 5 into 7 is 35, carry over 3, 15, 8 carry over 1, 31 carry over 3, 33. So this much into 10 power minus 20 joules. Yeah, but how many do I have? I have 1 mole of them. So 1 mole is what? 6.6. I'm sorry. 6.023 into 10 power 23 into 33.185 into 10 power minus 20. So you multiply these two, you will get the total energy in 1 mole of photons. So I'll assume this is 6, approximately it will give me the same. So 6 into 8 is 40, 6 into 5 30, 0 carry over 3, 41 carry over 51, 1 carry over 5, 6 1 6, 5 11, 1 carry over 1, 6 3 is 18, 19, 9 carry over 1, 6 3 is 18 plus 1, 19. So it works out to be approximately 199 into 10 power 3 joules. So I can write that as 1.99 into 10 power 5 joules, which I can say approximately is 2 into 10 power 5 joules. Yeah. So I found out the energy of 1 photon. What is the energy of 1 photon? The energy of 1 photon is h into f. Yeah, because the energy of 1 photon is that much, the energy of 1 mole of photons. So 1 mole of photons is 1 mole into this. Now 10 power 23 into 10 power minus 20 will give you 10 power 3. So I have 10 power 3. 6 into this will give me like 199. So from there I got 1.99 into 10 power 5 joules. Okay, so this was the second question. Yeah, first round of exams, which will be happening this month. By around after 2 weeks, you will be having exams. So by then, yeah. This week's test portion is full atomic structure. Notes, everything will come. Okay, so this one is over. The next question. A 10-watt bulb emits radiations of wavelength 6000 angstrom units. A 10-watt bulb emits radiations of wavelength 6000 angstrom units. The question is, what is the number of photons emitted? Photons emitted per second. Okay, so this is the next question. So let's understand, what does 10 watt mean? So 10 watt means 10 joules per second. Yeah, 10 watt means 10 joules per second. Now the radiation is 6000 angstrom units. So one photon has how much energy? Hc by lambda. That is 6.6 into 10 power minus 34 into C, 3 into 10 power 8 divided by lambda. Lambda is 6000 into 10 power minus 10 meters, right? So now when I work this out, 6.637, you can put no harm in it. So 3 will go 2 times, 2 will go 3.319. So it is becoming 3.3185 into 10 power minus 34 that I have here plus 8. This will go up and it will become plus. So plus 10, 3000 is here. So minus 3. So that will become 3.319 into 10 power minus 34 plus 8. So that is 18. So that will become 16. 16 minus 16 minus 3 is minus 19. So into 10 power minus 19. This is the energy in one photon. Okay. Suppose n photons are being released per second. So this is equal to how much? This is equal to 10. So from here I can say n is equal to 10 divided by 3.3 into 10 power 19. So that will be 3 into 10 power 19 photons are released per second. 3 into 10 power 19 photons are released per second. Okay. This is the third question. Fourth is exactly the same as the third one, so I'm not going to do the fourth one. Fifth one also I have worked out. It's about the energy content of light of light of wavelength 5000 angstrom unit. So that also you can work out. Okay, next I will do the sixth one. Yeah, 10 power minus 19 is divided, so it goes up and it becomes 10 power 19. My dear students, I don't allow somebody to copy just like that. You don't tell me slide 7 there is nothing. I don't understand unless you just want to copy it as it is. Okay, so I don't allow any copying business. So you better don't do it. But if we do it, we should know what we have done. So I'm not allowing any copying business. You ask a question, I will answer the question. This is divided by 10 power minus 19. Divided by 10 power minus 19 goes up and it becomes plus 19. So it is plus 19. Okay, so there is no copying business from the board. Please don't get into that. You have been copying all these calculations in your lower classes. That is why now we are not familiar with it. Okay, so copying doesn't help anyone. Only working out. You ask me a question, I will answer. I have no problems with that. No need to check. You do your work, get it to me, I will check and tell you. CB, let us not get distracted. Let us do our work now. Okay, I am not going to answer all those questions. When the time comes, I will tell you what your questions are, what your portions and all those things. I don't understand. You guys don't do what is expected from you at that time. And then again, no, sorry about it. Please focus on what we are doing. If you have any questions about what we are doing, please be here. Otherwise, move on, carry on. Don't waste your time. Those of you who have finished it, don't waste your time. Sixth one. The threshold frequency corresponds to 4500 angstrom units. Threshold frequency corresponds, I'm not writing the question, to light of wavelength 4500 angstrom units. Okay, now I'm asking you what is this energy in joules and electron volt. So joules, energy in joules is equal to hc by lambda. So 6.636 into 637 into 10 power minus 34 into 3 into 10 power 8 divided by 4500 into 10 power minus 10 joules. This is the total energy. Okay. Now, if this is the total energy, this will 2 will become 8. It will become 10 power minus 8. Yeah. So it will become 3 will go here 15 times. So it is equal to 6.637 divided by 15 into 10 power minus 34 plus 8. This goes up and becomes plus 8. Okay. So 15 will go, 15 fours is 60. So 0.4 60. So again 63, 0.4 is again 60, 37, 2. So 0.442 into 10 power minus, this is 16. So it will be minus 18 joules. So that is equal to 4.42 into 10 power minus 19 joules. Okay, this is the energy in joules. Next, I am asking you what is the energy in electron volt. So you can write down that 1 electron volt is equal to 1.6 into 10 power minus 19 joules. So 4.42 into 10 power minus 19 joules divided by 1.6 into 10 power minus 19 will give me the answer in electron volt. So 10 power minus 19 gets cancelled. So 16 into 3 is 16 into 2. 16 into 2 is 32. Okay. 32 means 122. 122 means 16 into close to 7. So it is approximately 2.7 electron volt. Now you can divide it exactly and find out what it is. Okay, so this is the second part of it. So I have first found out the energy in joules. Once I found out the energy in joules, I've converted it to electron volts by dividing it by 1.6 into 10 power minus 19. 10 power minus anything in the denominator, when it goes to the numerator, will become 10 power plus that much. Yes, I agree. I agree. It should be threshold wavelength. Yes. Yes, I agree. Instead of frequency, I should have put wavelength, or I should have put corresponding to. Okay, this is 2.7 electron volt. Then seventh question. The energy content of a radiation is 3 electron volt. Question is find out the frequency. Okay. So 3 electron volt is equal to 3 into 1.6 into 10 power minus 19 joules. Okay. So that is equal to 4.8 into 10 power minus 19 joules. Now 6.637 into 10 power minus 34 into frequency is equal to 4.8 into 10 power minus 19. So frequency is equal to 4.8 divided by 6.637 into 10 power minus 19 plus 34. So you have to find out what this is. So this will be equal to, I'll just, yeah, you all will have to learn to divide and then find out. So this will be equal to 4.8 divided by 6.637. So it is 72. So it is 0.72 into 10 power plus 15, or 7.2 into 10 power 14 hertz. So this is the frequency. This is how you convert electron volt to frequency. If you tell me the energy, I can convert it to frequency. Okay, so if this is done, let me find out. Yes, always you have to convert electron volt to joules and then start working. You message me the question. Message me the question. H into F is equal to energy. Now you should know what I am writing. If you are, I don't understand what to tell you. Yeah, where did I write H into F is equal to energy? Yes, H into F is equal to energy. So I don't know what you guys are doing. If you are just keeping your eyes, mouth, I mean ears shut and then copying, then I don't know. But H into F is energy. Then what else is this? Yeah, H into C by lambda is equal to energy. Then I don't understand what is it. H into F is energy, is equal to energy. Okay, energy is H into F. There's nothing else there. So Harish, I don't know what you are trying to say. I don't know. H into F is energy. Okay, so seventh one is over. Next, let's do the eighth question. So the eighth question, radiations of wavelength 3300 nanometer falls on an element. Electrons are emitted with energy, kinetic energy of electrons is equal to 1.68 into 10 power 5 joules per mole. Yeah, so now this is very interesting. They're asking you what is the threshold energy. Okay, so first they've given you the kinetic energy of electron in joules per mole. That means for 6.023 into 10 power 23 electrons, the kinetic energy is 1.68 into 10 power 5. So for one electron, the kinetic energy is going to be 1.68 into 10 power 5 divided by 6.023 into 10 power 23. So this is the kinetic energy for one electron. Okay, now the incident photon has lambda this much. So the incident energy E should be equal to 6.637 into 10 power minus into 10 power minus 34 into 3 into 10 power 8 divided by 300 into 10 power nanometer minus 9. So this 3 here gets cancelled. These two will make it 7. This will go up 15. So 34 minus 15 is 19. So I'll get E is equal to 6.637 into 10 power minus 19. So this is the incident energy. This is the energy. Yeah, this is the incident energy. So 6.637 into 10 power minus 19 is equal to, they are asking you for what is the threshold energy. So this is equal to the threshold energy plus kinetic energy of each electron, 1.68 into 10 power 5 divided by 6.023 into 10 power 23. Yeah. So now when this 10 power 23 goes up, it becomes 10 power minus 18. So this will become 10 power minus 18. Okay. So now 1.68 by 6.2, 12, 48. 6 into 8 is 48. So I'll make it 2.8 into 10 power minus 19. So this is equal to, this thing is equal to 2.8 into 10 power minus 19. This is equal to 6.37 into 10 power minus 19. So I can calculate ET is equal to 6.637 minus 2.8 into 10 power minus 19 joules. So that is equal to how much? That is equal to 3.837 into 10 power minus 19 joules. Yeah, what did I do? First, I was given the kinetic energy per mole. So the kinetic energy per mole of electrons, I converted it to kinetic energy of 1 mole of electron. So this is the kinetic energy of one electron by dividing it by Avogadro number. So then I found out what is the incident energy how did I find out the incident energy? I did E is equal to hc by lambda. Then I wrote my conservation equation, that is energy incident is equal to work function plus half mv squared. So I substituted for this and I substituted for this to get the value for this. Okay, so this is how you do the 8th question. 8th question. Okay, so this is the 8th question. Now the 9th question. 9th question is electrons have velocity 3 into 10 power 6 meters per second. What is the total energy per mole of these electrons? You can find out. I gave you the electrons energy for one electron. I am asking you for 1 mole how much it is. Next question, the threshold frequency for a metal is given. So now this time I have given you the frequency of the incident radiation threshold and I am asking you for kinetic energy. Here I gave you kinetic energy of the electron and the wavelength and I am asking you for, so you can work out the 10th question also. Then what is the radiation of the radiation emitted if an electron jumps from the 3rd shell to the 1st shell of an hydrogen atom? So an electron is jumping from 3rd shell to 1st shell. Okay, so in 3rd shell the energy is minus 13.6 into 1.6 into 10 power minus 19 divided by 9 joules. In the 1st shell it is minus 13.6 into 1.6 into 10 power minus 19 by 1. So the difference in the energy will give me the energy liberated. So it will become 13.6 into 1.6 into 10 power minus 19 into 1 minus 1 by 9. So this is equal to energy of photon. That is the radiation. So that is very simple. So it is 8 by 9 into 13.6 into 1.6 into 10 power minus 19. So I just need to calculate this and answer in joules. Okay. Okay. Eighth question. H nu is the energy photon is equal to work function plus kinetic energy of electron. Okay. Now radiation is given to you. So hc by lambda is given to you. This is equal to work function plus kinetic energy of electron. Kinetic energy of 1 mole of electron is given to you. Ke of 1 mole is given to you. So Ke of 1 electron is equal to Ke of 1 mole divided by 6.023 into 10 power 23. So Ke of electron is given, Hc lambda is given. They are asking you to find out work function. So you have to simply substitute and do. That is what I did. That is what I did. So this is the energy for 1 electron. This is the kinetic energy for 1 electron. This is the energy incident, Hc by lambda. I did Hc by lambda. Okay, only if you do these questions you will learn. Directly if you start and then you have to read. If you are just listening to what I am saying and then if you thinking that we will learn it, it is very easy like 10th standard. It is not like that. You have to be honest and you have to work. So that is the most important thing. Okay, so here is the kinetic energy for 1 electron. So they have given you kinetic energy per mole. 1 mole is 6.023 into 10 power 23. So kinetic energy per mole is to be found out. So I have found out. Then they have given me the wavelength. If they have given me the wavelength, hc by lambda is the energy. So I found out the energy. Then, so I have this equation. This is given to me. This is given to me. They are asking me for this. So this is equal to this energy minus this energy. So that is what I have done. And I have got my answer. Ninth question. I have given you threshold is equal to work function. Yes. Yes, hydrogen only. If nothing is mentioned, it is hydrogen. But in the question, it was mentioned that it is hydrogen. Ninth question. The electron has a velocity 3 into 10 power 6 meters per second. They are asking you what is the total energy of 1 mole of electrons. Total energy of 1 mole of electrons. So total energy is half mv squared into Avogadro number. So that is half into 9.1 into 10 power minus 31 kg. This is the mass of an electron into velocity square. So 3 into 10 power 6 into 3 into 10 power 6 into Avogadro number. So what is Avogadro number? 6.023 into 10 power 23. So this is the total energy. So I have to find this out. No problem. So this is 23. So it is equal to half into 9.1 into 3 into 3 into 6.023 into 10 power minus 31 plus 12 plus 23. So I can work this out. Yeah. So this is also approximately 3. So 27 into 9. 27 into 9 is 27 into 91. So 7, 2, 3, 24. So 2457. So it is 245.7. Yeah, into 10 power minus 30. This is 35. So plus 4. So 2.4546 into 10 power 8 joules. So this is the total energy for 1 mole of electrons. So energy, kinetic energy is half mv squared. So I'm asking you per mole. Per mole means into Avogadro number. So that will give you the total energy. Okay, fine. So this is no. Kinetic energy is always positive. Potential energy is negative. Here we are talking about velocity, energy because of velocity. Yeah, so that is it. Sharon, what type of questions I asked you this weekend? Same type of questions will be asked. Yeah. Yeah, mass is not given. It won't be given. Mass of an electron won't be given. You have to know that it is 9.1 into 10 power minus 31. Yeah. Okay. So work it out. I will expect all of you to submit this work by today. So please make sure that you are submitting all this work by today. Okay. I won't wait beyond today. Okay. Yeah. Bye. Adit, I don't know. Aditi. What do you mean by will the exam questions be also NEET type? Now, what do you mean by that? You mean to say what we are doing is not NEET type? I don't understand what you are trying to ask. So you guys know more about what the NEET question is going to be than your teachers. Then I don't understand. I mean, I don't understand in what context you are saying. When can we add? Tomorrow's class, we will be discussing the test questions. Yeah, this is the first slide. No, you won't have to study Thomson's model. Atomic structure is this is the last time I am telling. Atomic structure, full atomic structure is the syllabus for this week's test. Okay. Yeah, last class yesterday also I told 2 times. Rutherford's model you have to study. Whatever I have taught you in atomic structure, you have to study. Yes, for hydrogen, Z is equal to 1. So third shell means N is equal to 3. So by 9. That's what I am doing. By 9. That's why I am dividing it by 9. Tomorrow's class will be discussing the paper. Yes, you have to go with the NCERT book and notes. Now there is no difference between the NCERT textbook and notes. Yeah, notes are also there. Yeah. Thank you. Yeah, full atomic structure, whatever I have taught is there in your syllabus for this exam. Okay, yeah, bye.